Hey guys, today we're going to be doing the question that is regular expression matching on LeetCode. So as you can see here, it's told that we have given an input string S and a pattern P. So we have to implement regular expression matching with support for the dot character and the star character, where a dot can match any single character and a star matches 0 or more of the preceding element. So we have to match the entire S and P strings. Now P is the pattern string, P denotes pattern, and S you can say that it's the original string that has been given. So here if you see the first example, the string that has been given to us is AA and the pattern is given as A. So say we have the string here as AA and the pattern is given as only A. So if we match this, you can see that there is only one character that is matching, and then the other character is not present in the pattern. Like there is nothing present to match with the pattern. So we can automatically say that this is not going to match, S and P is not going to match. So next up, when we come to the second example, as you can see, there's a star. So what does star denote? Star basically denotes that whatever, if say S is AA and P is A star, so whatever character comes right before the star in pattern string, we can repeat that character for greater than equal to 0 number of times. Okay, we can repeat that character for greater than equal to 0 number of times. So we have to treat this A and star together as a unit. So we have to see that how many times this A has to be repeated. So here, as you can see, it has to be repeated for twice. Now, since it can be repeated any number of times that is greater than equal to 0, we can say that this unit can represent AA. So this matches with the original string that has been given to us. So we return true. Okay. So now next up, let's see the example 3. Now the example 3 basically gives kind of, like a very good case of this question, that is dot star. So if say we have a dot and a star followed by it in pattern, and in the string say we have anything, we have BC, sorry, not BC, let's take it as BB. Okay, let's take this as BB. So say we have BB. So in that case, what we can do is, like, we know that this star can represent any, like this star represents that the character that is present right before it can be repeated for greater than equal to 0 number of times. So we can repeat this dot for any number of times that we want to. We can repeat it twice. So both of here we can have B and B. Say this was a totally different character we have, that is B, D, C, D, E, C, G. We can repeat this dot any number of times, right? So we can like in place of the dot we can basically put any character. So we can just put B and B here, then D here, then E here, then C here, then G here. Okay, so we can just match it however we want to. Okay, so these are the few example cases that have been given to us. Now let's see some more example cases. Now say the S here is AD. Okay, and the pattern that is given to here is just A star D. Okay, A star D. So in that case, this whole unit can represent only one repetition of A, right? So this matches, these two match, and then D also matches, so we return true. Now say this is only D, S is only D, and the pattern is A star D. Okay, now since this unit can represent greater than equal to 0 repetitions of A, we can totally cancel out by having only 0 repetitions. So we can cancel out this A at all, and then we can just match this D, so the whole strings match, right? So this is how we're going to proceed. So now let's see how we're going to approach. Now see, although this is a LeetCode hard question, but you will see that how easy it becomes when you break it down into certain fundamental aspects. So what have been given? What are the criteria that has been given to us for matching? Now the first criteria is, say we consider the star, okay, the star units. So as we had discussed, that whatever character is present right before the star, we're going to treat the star and that character as a single unit, right? Because as you can see that in this question, in the constraints, it has been specifically mentioned that it is guaranteed for each appearance of the character star, there will be a previous valid character to match. So we can always assure, be assured that there is a character that is going to be present right before the star, right before every star that appears in the pattern string. So in that case, we can hold, with all those stars, we can consider the characters right before the star as a single unit, right? So now what we're going to do is, like, if this unit comes, if this unit appears in our pattern string, what are we going to do? One thing that we can do is we can have only 0 repetitions. Okay, we can have no repetitions of the character right before the star. Okay, no reps. Then one is that we have multiple repetitions of the character. Okay, multiple repetitions that is greater than equal to 1. Okay, so now let's approach this question say with a recursive approach. So say we have the string as ABC, and the pattern that we have is A star B dot. Okay, so let's just say that we move from the right of both the strings. Okay, the rightmost end of both the strings. So first of all, we have a dot here, right? Okay, so let's write on the case for the dot also. So if we see a dot, okay, if we see a dot, or if we see say an equal character, because we know that dot can represent any character, dot can match with any character that is present in S, right? A dot in P can match with any character that is present in S. So we don't need to see that if it is equal to some other character or not. So we can represent it with any character, right? We can match it with any character. So we can also say that this is also equivalent to the case when say we take an index of I in S and we take an index of named J in P. So we can also say that if S of I is equal to P of J. Right, this is the same case only, right? If both characters are equal, or there is a dot present in P that can represent any character in S, so both the cases are equal only. So this is one case that is present. So here in this case, what are we going to do? We know that both the characters are matching, so we can move both the indexes ahead, right? That ahead here means like since we're moving from right to left, so it will mean I minus 1 and J minus 1. So if we write the recurrence relation for that, we are going to write something like I minus 1 comma J minus 1. We are moving both the indexes backwards. Okay. Now we have this B and B, which is matching. Again, S of I is equal to P of J. Condition is satisfied. So again, this recurrence relation is going to be called, that is F of I minus 1 comma J minus 1. Now we come up to a star. Okay, in P we come up to a star, and in S we come up to this A character over here. Okay, so since we come up to a star, we're going to check this first condition over here. So in this, as I said, there are two conditions that we need to check. If we can have multiple repetitions, okay, if we need multiple repetitions of A that is present right before the star, we are going to treat, as mentioned before, we are going to treat this A and the star as one specific unit. So we're going to check that how many repetitions of A need to be present. So in order to check that, what can we do? We can first check that if say we are encountering this star at an index J in P, right? So we need to check if this character at J minus 1th index of P is equal to the ith index character of S, right? Because only in that case, because say since this A is equal to this A, only in that case we can have like multiple repetitions of A present, right? Only then we need multiple repetitions of A to be matched. Like say we had something like a C over here, okay? In this S we had something like a C instead of A. Now in this case, this A and this C don't even match. So we can say that we don't need any units of A over here, because the character that is preceding star is A, right? So we can use the star only to repeat those A's. We cannot use the star to repeat any other character than A. So we cannot use this to match with C. We can only use this to match with multiple number of A's present in S, right? We can use the star only to match multiple number of A's that is present in S. So that's why what we do is we first have to check that if now for multiple repetitions of A, we need to check that if P of J minus 1 is equal to S of I, right? So if this is true, only if this case is true, only in this case we have to include this one repetition of this unit of this character A and then move ahead, right? Or we can also say that we had a dot over here, okay? In this P, instead of this A, we had a dot. So as we know, the dot can represent any character in S, right? It can be matched with any character in S. So if we have a dot followed by a star, as we also checked in this example 3 as we did earlier, we had seen that it can match any character. So in that case also, it is equivalent to both the characters in P and S becoming equal. So we have to do if P J minus 1 equal to S of I, or if P J minus 1 is equal to a dot. In both these cases, we are going to move ahead. Now move ahead, what do we mean by moving ahead here? Now once we have got multiple repetitions, now after this what we can do is we can call the recurrence relation of I minus 1, right? I minus 1 comma j. Okay, perfect. Yeah, right. I minus 1 comma j. Now why are we calling this? We are calling this to hope for even more repetitions of a in the future. Okay, like say we there were 3 a's over here. Okay, say there were 3 a's over here, so we needed 3 repetitions of a, right? Now there is only a star, there is only one unit of a present over here. Now we needed multiple units, we needed multiple repetitions of a to be matched, right? So we are doing f of I minus 1 j so that I moves backwards, but then j stays right at that unit only. J stays right at the star only, so that this unit can be used to repeat even more number of a's, right? So that's why we're doing only I minus 1 comma j in the recurrence relation, right? So now say that like this, say there was only one a. Okay, there was only one a, and say that there was a d right before that a in S. So in that case, what we're going to do is we are like when the next recursive call happens, in that case this condition for multiple reps, this condition, this if statement over here is not going to be fulfilled. In that case, we don't need any more repetitions of the current unit, that is a star, right? We don't need any more repetitions of a, right? In that case, we are going to call the function that is f of I comma j minus 2, right? Now why are we calling j minus 2 here? Why are we doing j minus 2 index? See, the unit, as we say, like for every unit, like for every star, the like for every star that is say present at the index j, the character that is present at j minus 1 and that jth index star, those both characters, the star and the character that is present right before it, they have to be treated as one single unit. So if we need to skip that unit, if we don't need any more repetitions of that unit, we need to go from j to j minus 2, right? By skipping that character, because that was also part of the unit. So that's why we call the recurrence relation of I comma j minus 2. Okay, so this is all the recurrence relations that we have called. Okay, now doing this, what are the base cases? Okay, let's erase this d. What are the base cases? So say that by doing this, we have reached the end of this s, that is I becomes less than 0, right? And say we also have reached the end of p, that is j less than 0, right? So in that case, if I less than 0 and j less than 0, this is the first base case. If both of these are true, in that case we will simply return true, because both the strings have been traversed completely and we have matched both the strings completely. We have matched the pattern string with the given string. Okay, now what if only I is less than 0? If only I is less than 0, that denotes that we have only completed traversing the original string that we have been given. Now we have not yet completed traversing the pattern string. Now when can this case occur? Okay, now say there is the pattern, the string s given to us is abc, and the pattern given to us is a star b star abc, right? So if we move from the end, this abc and this abc gets matched completely, right? So here for s, the I reaches at the left end, but for p, the j doesn't reach the left end of p. That is, j is not less than 0. J is not less than 0. J is still at an index that is middle of the p somewhere. So this can only happen, we can only traverse even more in this case only if there are these star units present. There are these units of star present. Now what did we discuss about these star units? That if a star is present with a character that is right before it, we can repeat that character for greater than equal to 0 number of times. So we can also repeat it for 0 number of times, right? Since it is greater than equal to 0. So we can also repeat it for 0 number of times. So here we repeat b for 0 number of times and we repeat a for 0 number of times again. So we reach the left end of the p string also. So in this case, if only I is less than 0, if you have reached only the end of the s string, in that case we can move ahead. Only if p of j equal to star, right? And if this is happening, then we're going to do f of I comma j minus 2. We're going to skip that unit as we had discussed earlier. Okay, now what if only j is less than 0? If only j is less than 0, that means we have completed traversing the pattern string, but still there is a part of the original string, input string, that has been left to match. So we don't have any more of the pattern left, right? We don't have any more of the pattern left. Then what are we going to match it with? We don't have anything left. If some part of the pattern string only is left, we can see that if the star units are present, we can still skip it. But if there is no pattern left at all, what will we match with the rest part of the input string that has been given to us? So in that case, we are simply going to return false, because there is no way that we can, match the rest of the part of the input string given with any part, because there is no more expression that is, left in the P string. Okay, so these are all the base cases. These are the 3 base cases that we need to know about, and these are all the recurrence relation. Okay, recurrence relations. So now let's jump right into the code. So first of all, let's write the base cases. Now it is advised that whenever you write recursive code, you should write the base cases at first, so that you can visualize properly that where are all the base cases written. So yeah, so let's go on with the code. So let's say we write a recursive relation at first, recursive function at first. So we take the indexes as I and j, as we mentioned before. We take the input string is s, and the pattern string is p. So first of all, we write the base cases as discussed earlier. So what were the base cases? The first base case was if I less than 0 and j is also less than 0, right? So if I less than 0 and j is less than 0, in that case we are simply going to return true. If only I is less than 0, in that case we would return true on we would have to check if p of j is equal to star, right? If p of j is equal to star, then we will return the recursive relation of I comma j minus 2. Right, this is done. But if it is not equal to star, then we have to return false, because if we cannot match it with any other character, right? Because only if the star units are present, we can have 0 repetitions of all the characters, and then we can move ahead. Right now, if only j is less than 0, in that case we had to return false, because there is no other case we can match it with. So yeah, it's done. So we are done with the base cases. Now let's write the recurrence relations. Okay, so let's move on with the recurrence relations. So first of all, we're going to write that if this p of j is equal to a star, that is if there is a star unit present, right? If there's a star unit present. Okay, so let's take an initial result as false. Okay, false. So if there's a star unit present, we obviously need to check if the character right before the star is also equal, that it can be matched with the character like at the ith index of the s string, right? Or if the p of j minus 1 equal to a dot. So if it is a dot also, it can be matched, because since the dot can be matched with any character. So res equal to res or recur of we had to move I minus 1 comma j, right? Because we are checking for multiple repetitions over here, right? We just do this j I minus 1 comma j comma s comma p, right? Now say that say that there are no more repetitions needed. In that case, we are also going to be needing to do this res or recur of the recurrence relation, as you can see, I comma j minus 2, right? So I comma j minus 2 comma s comma p, right? So this is all we need to do for a star unit. Now if it's a dot, okay, if it's a dot or say the characters are equal, okay, if the characters are equal, in that case what do we need to do? In that case, we simply need to return the recurrence relation of both the indexes moving backwards, right? Because in that case we have already the matched character, so we don't need to assess we don't need to find out anything else over here. We can simply forward both the indexes. But if none of the conditions occur, in that case the only case that holds is that both the characters are different. So at any point if we find that the characters in both the strings are different, in that case we always have to return false. Okay, so this is the code that we've written. Now let's see if this runs or not. Okay, so perfect. So let's return this recursive call of since we need to traverse from the right end, so we need to give the last indices, and let's give, yeah, so let's see if this runs. So as you can see that it runs for the example test cases. Now let's submit it and check. So as you can see, it is submitted successfully. So this was the code for basic recursive based approach. Okay, so now how do we optimize this code? Since this code is going to take a lot of stack space, and also it's going to do a lot of extra recursive calls in order to find out the solution for us. Now this is accepted here because in the constraints here, the length of S and P both are small. So it doesn't really matter that how many repetitions take, how many calls take place. So but if we need to optimize this further, we can apply dynamic programming approach over here. First of all, let's check that how can we do it using memoization. So we simply take a 2D DP array. Say we take it for like zeros and ones. Okay, so we just take it as DP. We just name it as DP, and the first dimension that we give it is of s dot size. Okay, and the second dimension that we give it is for the p dot size. Okay, and we initialize it with zeros. Okay, at first. So let's say we pass this DP array over here. For every recursive call, we pass this DP array. Perfect. Done. So yeah. So like we will like after all the base cases are assessed, we will see that if this dpij is not equal to, okay, let us initialize this with -1. Okay, -1. So we're going to check here that if dpi of j is not equal to -1, then we're going to simply return dpi of j I comma j. Right, done. Now where are we going to memoize this? We're going to memoize this over here. Wherever we are returning it, we are going to memoize this. So this is a general type of memoization technique that that you can do, that just before returning your just before, like, whatever value you're going to return in every recursive call, right before that you also have to memoize that value into like whatever indices you are using in order to represent that specific recursive call. So here, since we are having two specific indicators, that one is the index in the string s and one is the index in the string p. So here we are taking only these two indicators, only these two indices for for indicating that what the dp array needs to memoize. So here, for every value of I and j, the dp array will basically memoize that whether we can match whether we the characters right before the I index in S and the characters right before the P index right before the J index in P, the string P, can be matched successfully or not. So if it has like say false already stored in the DP array, it means that that part can be matched till J and I, that part can be successfully matched. So the next time whenever that same recursive call of I comma j occurs, for that value of I and j, if a value that is not equal to -1 is already stored in the array, say it can be 0 or a 1, right? If it is already stored in the array, in that case we will simply return the value of dp I comma ij without having to do all the processing again. So that's all about it. dpij, wherever you are returning the value, right there you also need to store the value in your dp array for that specific I and j values, right? So yeah, we've done over here. So as you can see, even here like in base case, now here see, you don't need to write, you don't need to memoize while you are in the base cases, because as you can see here, I is already out of bounds. So if you try to memoize over here, you can't access the ith index of the dp array, right? So you obviously will be thrown an error over here. So you can memoize the results only after the base cases. Okay, yeah, so that's all about it. So yeah, we have memoized. Let's run this. Okay. Okay, fine. I need to pass the DP array also. So wherever I'm calling, making the recursive calls, I also need to pass the DP array. Yeah, that's, I think, yeah, this is all about it. Yeah, I think this should run. Yeah, as you can see, this is running for the example test cases. Yeah, perfect. It got submitted also. Now, how do we optimize it even further? Now, say we we need to develop a tabulation approach for this question, right? So I will give you a very simple approach that you can follow to convert any memoization code into tabulation code. Okay. Now, so I am going to be giving you a approach that I follow in order to convert the memoization code into tabulation code. Okay. Now again, let me give up a disclaimer that this is just a general approach that I follow to, you know, kind of similarize the code between memoization and tabulation. It just might be a little different in certain cases. So this is just a general approach that I follow for just visualizing the code all over. So in memoization, as you can, as you have seen, that what we do is we call a specific recursive function. Say we call this I comma j. Okay. So say again inside this call we are making a call of I minus 1 comma j minus 1, and then we are making one call of I comma j minus 1. So like this we keep on making certain calls, and then for one call, like whenever say we reach the base case, we return a specific value. So that value gets stored in a certain a certain index, that value is returned from a certain recursive call, right? And for that specific indicator, we store that, we memoize that value in our DP array as we had seen earlier, right? So this is what we do in terms of memoization. We start from we start from the larger values, we break it up into smaller values, and then we reach the base case, we return some value, we keep on memoizing the smaller values first, and then the in order to calculate the bigger chunk of values, we will use those smaller memoized values in order to do so. But in tabulation, what we do is we go into a reverse direction of memoization. You can simply remember, like, this is a very very basic and a very fundamental and a very useful useful idea that you can follow in order to convert the codes between these two approaches. So you go in reverse direction of memoization. Here you are going from the large you're going from the large values to calculating the you're going and terminating right at the base cases, and then you are moving from the base cases you are returning certain values, then again those smaller recursive calls are going to return some values. But in tabulation we start itself from the base case. We start from base case and we develop a general trend or a general formula or a general you can say a general pattern in which the values were getting stored in memoization. So we are developing that general pattern, and we are keeping on modifying that DP array that we have, and we will do that starting from the base case. Okay, now let's see how we do that in the code. Okay, so let's say we have this same DP array over here. Okay, we have the same DP array over here. Now what we basically do is now let's comment out this code over here. So I will show you that how simple it is to basically convert any recursive code like any memoization code into tabulation code. Okay, so now whenever you will have to convert this memoization into tabulation code, you need to keep take care of one thing, that is the base cases. Okay, that is the condition of the base cases. Now here, as you can see, you didn't need to store the base cases values. Okay, in memoization you didn't really need to store the base cases value in the DP array. you just called the function calls, and whenever you encountered that base case, you simply returned a value. Okay, you didn't need to store anything there. But when you are doing tabulation, you need to start from the base case. You also need to store that value of the base case. So how will we do that? We will simply do nothing but just say we had the DP array, we had the DP matrix like this in memoization, right? We are simply going to add one more row and one more column. Okay, we're simply going to add one more row and one more column, just so that we have this like this row and this column is just for storing the base cases. Okay, this row and this column, extra row and column, is just for storing the base cases, and whatever indexes we are going to store the further indexes in, like we are simply going to add one index, like while storing, like in memoization we were storing in whatever indexes, we are just going to store it in an index that is just added. We're just going to add 1 to all those indexes, and we're going to store in the DP array. Okay, in the case of tabulation. So let's define the DP array over here for our tabulation approach. So let's say we do this, and as we mentioned that we have to have one row and one column extra. Okay, so one dimension extra for each. Right, p dot size plus 1, and we're going to fill it with say we're going to fill it with 0. We can fill it with 0 or -1, anything. So initially dp of 0,0 is going to be 1. Why is that? Because for the base case over here, see, whenever you are converting the code of memoization into tabulation, you are going to follow the exact pattern in which the code you have written over here. First of all, I'm going to be converting the base cases. Okay, I'm going to be converting the base cases. So say I'm going to be converting the base cases. First of all, the base cases, if I reaches the end of the string s, and if j reaches the end of the p string, right? In that case, we are going to return true. So I'm storing the same base case here as 0 and 0. As I said that, like, we can't store it in negative indices, right? So we need to shift one indexes ahead in the DP array and do all like +1 to all the other indices that are present. Okay, so that's done. We have stored a true over here in DP 0,0 for this base case. Okay, let's mark this as base case 1. And again for the base case 2, what we're going to do is the condition is that if I is less than 0. Now for the rest of the base cases, I think we can do it inside the loop that we're going to run. Okay, so how are we going to decide that how many loops to run? Okay, now see, here you have two indices, right? So for every value of I, you have to run a loop for every value of j, and for every value of j, you, like it's the same thing. So for every value of I, you have to run a loop for every value of j. Okay, so we are going to have a nested loop over here, which is going to, now since we had an extra dimension over here, okay, and we had okay, so we're going to run till the last dimension. So we're going to run a nested loop. Okay, j less than equal to p dot size j, right? So inside this nested loop, what we're going to do is we are going to now see for dp like this for this base case 3, this is basically that if j reaches the end of the like string p and I doesn't reach the end of the string s, so in that case all the values are going to be false. So in since we've initialized the dp array with zeros, so basically for the cases, so like this basically denotes that the 0, that is j is equal to 0, all the values for j is equal to 0, that is the first column, of the this is j is equal to 0, right? So the first column should be totally covered with zeros. All these should be zeros except the 0,0, which is we have already assigned as 1. So except this one, all these values should be 0. So this is already, since we have already initialized it with 0, so they are all going to say 0. So this base case 3 is also satisfied. Now what about this base case 2? We're going to write this base case 2 right over here. Okay, if I is less than 0. Now if I is less than 0, I like that basically here, since we have shifted all the indexes of like +1, so here we're going to write the base case as I is equal to 0. So if I is equal to 0, we're going to like literally we're going to have the same code copy and pasted here. Okay, just copy paste the same code over here, exact same code. So here if p of j, now see, now since we had like for the DP array, for accessing the DP array, for indexing in the DP array, we had shifted all the indices by +1, but then the indices of p, the string p that has been given to us, that stays intact, right? So if we like this j, the last value of this j goes to p dot size. Now if we try to access this index in the string p, that is going to show us out of bounds error. So in that case, what we need to do is we just need to decrease this value by 1, like for p, because in the string p we don't need the values going +1, right, for every index. So here we are also going to start from 1, since for j is equal to 0, I had already explained the base case 3. For j is equal to 0, the values are already initialized as 0, right? So we will just continue from j is equal to 1. That will also not show an error when j minus 1 is done over here. Okay. Now take a very good look at it. Wherever we have this recursive relation call, okay, only there we need to just replace this recursive relation call with the DP array relation. Okay, we just will do this. Let's comment this out. We'll just simply do DP I of j. Okay, like for the current value, for the current combination of I and j, we are going to store. Okay, whenever we are going to store, we're going to store for the current combination of I and j. And what are we going to store? We have to store a value that has been present, that has been stored already, right? That is we have already stored earlier. So what we're going to do is index it the same way in which we had called the recursive relation. Here we had called the recursive relation with I comma j minus 2, right? Here we're going to do I comma j minus 2. We're going to just store the same value over here in the DP array for I and j, right? Done. We can do remove the return statement, right? And here just the same way, DP ij is equal to false. It's as simple as that. Okay. So now when we move out of this base case, we have covered the base case 2, we've covered the base case 1, we've also covered the base case 3. Now when we have the star, the condition for the star and the dot or equal characters, just the same way we are going to copy and paste it over here also. We just copy and paste it over here also. Let's align this so that it can be understood properly. Okay, this is done. Okay. So if p of j, now again we like for the p we need to shift like one index backwards, since already for accessing the DP array we have shifted one index forwards, right? So wherever p the index is accessed in p, we just need to do -1 there, since it was already -1 here. So we do one more -1, so that becomes -2, j minus 2 is equal to s of I. Now also for I we had increased one indices, right? So whenever we are accessing the string, the indexes are like they need to be within the range. Okay, again this is going to be I minus 1. Okay, this is again going to be I minus 1. So done. So p again j minus 2, right? J minus 2 again here, as you can see over here, this rest that we have, this res is the value. Like here we can just simply, instead of res we can just write dp of ij, since that is the value that we are going to store it in finally. So at last we're going to return that res only. So instead of that we are just storing it in directly in dp of I comma j. So we just simply do here dp of I minus 1 comma j, right? As I said, we have to store it with the same index combination that was present in the recursive call, right? So that is done. So we have done this, right? Okay, let's write this a little bit less confusing. dp of I minus 1 j, right? Done. And what we need to return is again dp of I. Whenever the return statements are there, we just need to remove the return statements. dp of I comma j, ij is equal to dp of ij, or dp of I comma j minus 2. Just the same indexes in the DP array we have to access. Okay. This is the easiest way that you can convert any memoization code into tabulation code. Okay. In just a few simple steps. Again here, as you can see, we have to change the index of this to j minus 1 and I minus 1. Again, dp of ij is equal to recurrence relation of I minus 1 comma j minus 1, right? So we simply need to do here dp of I minus 1 comma j minus 1, right? So this is converted. It has been successfully converted. As you can see, there was just a few simple steps in which you could just copy and paste the code from your memoization code, and you can just make a few changes and you can just convert it into tabulation code. So let's return the final value. Now the final value is obviously going to be stored in dp s.size. That is the the last index of the dp array. Okay. So it's going to be stored in dp s.size and dp comma p.size, because that's where the last this last index of the dp array, this is where the answer is going to be stored, right? Because we had, like, generally we were following the trend in which both the indexes were moving from I was moving from 0 to s.size, and j was moving from again 1 to p.size. So the last index for both I and j is s.size and p.size. So that's where our answer is going to be stored. Okay, like that basically denotes that here it basically denotes that till the index, like whenever you say this dp of ij in this tabulation approach, this will basically denote that whether all the characters before the index I and all the characters before the index j in string p and string s respectively, if all these characters can be matched. Okay, so this is if this is true, that means that all the characters before index I in string s and all the characters before index j in string p can be successfully matched. If it is 0, then they cannot be successfully matched. As simple as that. Now I think I said the opposite while denoting this dpi comma j for memoization. For memoization, this will basically denote this dp I comma j is basically going to denote the opposite, like in the opposite direction. So if it is 1, then all the characters on the right side of this I in string s are can be matched with all the characters on the right side of index j in string p. Like here we were since we were moving from left to right, and that's why the like in tabulation, since we are moving from left to right of the string, in that's why for every I and j, the dpi of j will denote in this trend, that's that all the characters in lying on the left side of I index in string s and on the left side of index j in string p can be matched. And in memoization, since we are moving in totally opposite direction, so in that case it denotes the right side, the part of the string on the right. So this is what I mean to say, that the basic 3 points that you need to remember while converting any memoization code to tabulation code is, first of all, the tabulation code is always going to always try to make it run in reverse direction of memoization. So that way you can always kind of have that fundamental alive inside you, that why memoization and tabulation are basically called bottom up approach and top down approach, because they are basically moving while storing the values, they are moving in the opposite directions. Like in memoization, you move from the larger values and you divide them into smaller parts, and then you find the calculation, you find the results of the smaller parts, you store them in the array for certain set of indicators, and whenever you need to calculate the larger results, you access those small results, and then you combine them and you form the answer for the larger results. So but in the tabulation approach, you go in the opposite direction. You start from the smaller results. You already know the smaller results. You start from the very small results. Then you find a general trend or pattern in how those results are going to get modified. And this general trend or pattern, as we saw in this code, while converting the code, we saw that the general trend or pattern is exactly the copy pasted version of what was present in your memoization code. So you just don't need to do anything. You don't need to apply any brains. You just need to find that general trend or pattern in which the values are getting stored right from your memoization code. And you just need to accommodate those base cases in your DP array by changing certain indices, by just adding that extra row and that extra column. You can also store the base cases in your DP array. So that's a few changes that you need to make. But apart from that, everything is essentially the same. You just need to keep these 3 points in mind while converting your code from memoization code to tabulation code. Okay. Yeah. So let's run our code and check if this tabulation code that we converted from the memoization code is actually right. So, so you can see there's an error. Yeah. So I think here, after the base case, after the base case is actually executed, we don't need to go again checking for a star, right? Because if I is equal to 0, right? Like if I is equal to 0, in that case, we don't need to, we already have that base case. So whenever we go into the base case, like in the memoization approach also, whenever we went into the base case, we just returned certain values, right? For every base case, we were returning certain values. Like those were you can say those were the smallest, those were the places where the control goes and it terminates. Okay. So base cases are meant for that itself. So here also what we need to do is once we move into the base case, once we store that value in the DP array, after that we don't need to check the other conditions. Okay. So we just put an else over here and an else over here also. And yeah, because it can either be a star or a dot or some other character, right? So it can be all at once. So we don't need to check all the conditions. We can just put an else if over here. So yeah. So as you can see, this is giving a wrong answer for the first test case, that is A. Okay. Okay, so I think the mistake is because here we had forgot to remove the return statement. Yeah. So yeah, let's run this once again. So yeah, you can see all the 3 test cases passed. Let's submit it. So yeah, as you can see, it has been submitted successfully. So you can see that how in this code we had found out an efficient, very fast and simple way of converting memoization code into tabulation code. Now I have personally found this helpful for a bunch of DP questions, like a lot of DP questions that I have done. I have found this useful to convert, to follow these simple 3 steps and to convert your memoization code into tabulation code. So you just need to copy paste the memoization code and you need to make a few changes in the indexes of the DP array to store the base cases, and you can simply convert the same code, the same recurrence relations into your iterative code. So that's what you can do in order to convert your memoization into tabulation code. And coming back to this question, we saw that how for these regular expression matching, or say any kind of expression matching questions, we can simply move in a certain direction of both the strings, and we can simply break the question down into all the conditions that have been given to us. Like here we have been given the condition of a star and the condition of a dot. So we can break the question down into those conditions, and we can break them further down into whatever sub conditions all of them are having. Like in your star, for every star that is coming, you can have no repetitions, as well as you can have multiple repetitions of the character lying before it. So just like that, you can have multiple sub cases. So you need to divide those your expression matching question into certain cases and sub cases, and for every sub case you have to write one recurrence relation at first, and then you can convert this code into the memoization code. And I've also shown you how to convert the memoization code into your tabulation code in order to save the auxiliary space of the recursive calls that were happening. So yeah, so that's all about this question. You can do various similar questions on other platforms as well regarding to expression matching with DP. And yeah, that's all about this question. If you have any doubts, you can feel free to reach out in the comment section.